The crankshaft position sensor, CKP, in internal combustion engines, monitors both the position and rotational speed of the crankshaft. This data is sent to the engine control unit, ECU, which uses it to adjust critical parameters such as spark timing and fuel injection, ensuring optimal engine performance. Depending on the type of crankshaft sensor, the signal sent to the ECU can be analog or digital. Among the most common issues affecting this sensor are overheating and failures in the electrical circuit. Excessive heat can damage the sensor's plastic coating, while wiring or connection issues can disrupt signal transmission. These failures can manifest through various symptoms, such as A. Difficulty starting the engine. B. Irregular acceleration. C. Activation of the check engine light. D. Erratic engine performance with vibrations and misfires. E. Poor acceleration and excessive fuel consumption due to inaccurate injection. F. Unstable idling. Additionally, the crankshaft position sensor may be associated with several OBD2 error codes. P0335 indicates that the ECU is not receiving correct signals from the sensor. P0336 suggests unexpected signals, possibly due to issues with the sensor or wiring. P0337 appears if the signal received by the ECU is lower than normal, which could indicate a defective sensor or an issue in the electrical circuit. P0338. The signal is abnormally high, which could also indicate a sensor or electrical connection failure. P0339. This code points to an intermittently cut signal, which may cause ignition problems or engine stalling. How to identify the type of crankshaft sensor? There are crankshaft sensors that require a power supply from the ECU and others that generate their own voltage signal. A. Hall effect and optical sensors. These usually have 3 wires, one for power, typically 5V or 12V, one for ground, and one for signal. B. Inductive or variable reluctance sensors. These typically have 2 wires, signal and ground, and do not require external power, as they generate their own voltage as a signal for the ECU. How to test a Hall effect or optical crankshaft sensor. A. Set the multimeter to DC voltage mode. With the sensor connected and the engine off, but with the ignition in the on position, connect the red lead of the multimeter, while the black lead remains on another pin, switching them until you get a reading of 5 or 12 volts. This will confirm that the wire connected to the red lead is the power wire, while the black lead is on ground. The third pin will be the sensor signal wire. B. With the engine running, set the multimeter to voltage mode, and connect the red lead to the signal pin and the black lead to ground. The reading should fluctuate around 5V, changing as the sensor detects crankshaft movement. If the signal is constant or inconsistent, the sensor might be faulty. How to test an inductive crankshaft sensor. A. Inductive sensors generate an alternating voltage signal, which increases with the crankshaft's rotation speed. B. Set the multimeter to AC voltage mode. C. With the engine running, or by manually rotating the crankshaft, measure the voltage at the sensor terminals. A good sensor should produce an alternating voltage signal, which at idle is typically between 0.2 and 2 volts and increases with engine speed.